Alright, so welcome to this lesson on how do we work with the Pythagorean theorem or Pythagorean theorem, whatever you want to call it, still the same. So your objectives right here, so I can factor a polynomial, I can visualize the product of two binomials, I can solve a quadratic equation by factoring, I can find the length of any side of a right triangle, so on and so forth. Let's move on to our mini lesson. So, many of you are already familiar with the Pythagorean theorem. C squared equals to A squared plus B squared. Now, Pythagoras, I think it was from a town called Samos. And basically, most of his attributes or his theorems are basically, believe it or not, I would accredit them to his pupils. Okay, they are the ones who did the hard work. He was just collecting all the information. Now, it's amazing, but this is how he did it. He said that the squares, so then squares are squares like this, square, okay, the square of one side, the area of one square equals to the square of another side, right? So let's put another square here, okay? He said that the area of the larger square is equal to the area of the two other squares. So in other words, if this was 3, this was 4, and this was 5, the length of each of the squares. You know that in a square all sides are congruent. In other words, equal in measure. So if this is 3, this is 3, 3, 3, 5, 5, 5, 5, 4, 4, 4, 4, and so on and so forth. So let's find the area of this square. Guess what? The area of a square can be found by just squaring the side. In other words, if you don't like it like that, then you could say length times width. Okay, that's how you find area. Length times width. So length, this length is 3 times the width is 3, that's 9. Or you could just say 3 square is 9. 4 square is 16. 5 square is 25. If you add 9 and 16, you will get 25. That's basically how he did it, of course. We did it on paper right now. He was doing it with rocks, okay? He used to shape and sculpture like the rocks in square shapes. So that's how he did it. Alright, so something peculiar is this Pythagorean triplets. 3, 4, 5, 5, 12, 13, 8, 15, 17. Now, how do we come up with this? Oh, that's easy. Alright, for example, we just did a 3, 4, 5. Look, the larger number will always be the hypotenuse. Okay? In a right triangle, these are called the legs, and the larger side is called the hypotenuse. Now, how can you recognize the larger side? It's always opposite to the right angle. So if you are in doubt, just draw an arrow from the right angle, and it will point to the hypotenuse. Make sense? All right then. So let's move on. So the triplets. 5 squared plus 12 squared, in other words, 25 plus 144 equals 169. Yes, that's true. And then 64 plus 225, I think that's what 15 square is, 225, okay? That should equal 17 square. What is 17 square? 17 square is nothing more than 289, okay? Now, can we create our own Pythagorean triplets? Sure. I'm going to show you something. I can create one like this. 6, 8, and 10. Now, for 1 point, what did I do to these numbers to create these numbers? 5 seconds. Okay, time is up. So if you answer, you got the 1 point. If not, then forget it. Now here, can I create another Pythagorean triplet? Sure. 10. This one would be what? 24. And this one would be 26. Okay? So 10 squared plus 24 squared should equal 26 squared. And so on and so forth. Sorry. And you could create as many Pythagorean triplets as you want to. Look, this one. From the originals, how do you think I got these numbers? 9, 12, and 15. 9 squared plus 12 squared equals 15 squared, believe it or not. 81 plus 144 is 225. All right then. Let us move on. So the example. Remember something. If the hypotenuse is equal, okay? If the area right here, okay, is equal to the sum of these two areas, then guess what? To find any of the other areas, all I have to do is subtract from the area of the larger square. In other words, if c squared equals to a squared plus b squared, then a squared is equal to c squared minus b squared. Oh, or if I want to find b squared, then I would do c squared minus a squared. And at the end, as usual, at the end of every Pythagorean theorem, they will always ask you to find the length of the side. The length of the side is not represented by x squared or by c squared. It's represented by c or by x, a linear term, something to the first power. So how can I undo this square right here? Well, you always have to take the square root. Now, if you don't want to deal with this, then write down the variations of the Pythagorean theorem. For example, if I already know that I am going to take the square root of this and end up with c, then this is how you can write it. Okay? See that? I'm taking the square root of a squared plus b squared. Again, if you want to find a, then you take the square root of what? I said that you only add when you want to find the hypotenuse. Then the rest you subtract from c squared. And last but not least, to find b, you do c squared minus a squared. Okay? Now write this down, because this is going to come in handy when you want to find length of either the hypotenuse or the other two sides. Alright, let's go on to check your understanding. Let's see if we got this. It says, which set of number does not represent the sides of a right triangle? Justify your response. Alright, so which is not a right triangle? What is the criteria for a right triangle? That a squared plus b squared equals c squared. And I said the larger number is the hypotenuse. So in other words, for 1, right, I'm going to have 6 squared plus 8 squared equaling 10 squared. So I know that 36 plus 64 equals 100. If you have any questions, ask and I will explain. So 36 plus 64, is it 100? Yes. So guess what? This is a Pythagorean triplet. So no, this is not the answer, because they want the one that is not. Alright. So what you're gonna do is you're gonna check each of these to see which one is not, or which one does not represent the side of the sides of a right triangle. Alright. So take 1 minute to do this. The first one who gets it, raise your hand. Okay, the first few people, raise your hand and tell me what you did, and I'll give you 1 point. Alright, let's move on to the next problem. Okay, triangle ADB. In triangle ADB, measure of angle BDA is 90. Oh, okay, so I know that this is 90. That's how you recognize on how to label the right triangle. Okay, AD is 5 square root of 2. AD is 5 radical 2. We've been through this already. AB is 2 radical 15. AB, the hypotenuse, is 2 radical 15. Okay then, so what do they want? What is the length of BD? Oh, let me call this X. Okay? Now watch this. Do they want hypotenuse or they want a leg? They want a leg. Okay, let's label this triangle. I don't know, I'm gonna call this A, I'm gonna call this B, and I'm gonna call this C. Well, the hypotenuse is always C, so of course, it's given. So I need to find B. You could have labeled this B and this A, and then I would have to find A. So it doesn't matter. So I'm gonna find B. So I told you this was gonna come in handy, because you have to use this variation, unless you wanna use this one, and then you have to solve for B. Okay, so B is equal to C squared minus A squared. Alright, so that's what I'm gonna do. So B equals to the square root of, okay, what did I say? C squared minus A squared. Alright, so first let's figure out what C squared minus A squared is. Alright, so this would be, I'm gonna write it down here. B would be equal to the square root of, now let's see, C squared is, and look how I write it, 2 radical 15 square minus 5 radical 2 square. 5 radical 2, you see, you know what, next time don't close the radical sign because symbol, because we don't know how much we need. So 5 radical 2 square. So let's figure out what this is. You could take the calculator, okay, and you could say, okay, 2 radical 15. So you write it like this, parentheses. Every time you're gonna square or raise something to some power, put parentheses. 2, okay, radical. How do I radical? Easy, like this, second, and then radical. Okay, which radical? Here. 15, okay. Move over and close the parentheses. Now raise it to the second power. That is 60. Oh my God, I didn't do it. Okay, here. After the radical sign, you gotta move over. Okay. Let me make this smaller so you could actually see. You move over. Let me do it again. 2 radical 15. Okay. Move over. So you see, it stops expanding. Close parentheses, and then raise it to the second power right here. And then you get 60. Ah, nice. Okay then, so B equals to the square root of 60 minus, and I need to know what 5 radical 2 is. Okay, you know what? I'm going to do this by hand. 5 squared is 25 times, because 5 radical 2 means 5 times whatever is in the radical. So 5 squared is 25. Radical 2 square, guess what? When you square a radical, you cancel the radical symbol. So radical 2 square is nothing more than 2. So 25, okay, squaring times 2 is 50. Ah, by hand, nice. Last but not least, 60 minus 50 is 10. And that's it. Radical 10 cannot be simplified to a simpler form because this is the simplest form. Okay, there are no 2 factors of 10 in which one of the factors is a perfect square, so I cannot do anything. Alright, good then. Let's move on to the next problem. Alright, this is a big problem. Stop the bloody, stop the bloody. I'm gonna do it. I'm about to do it. I'm about to do it. No, I'm not gonna do it. Alright then, so let's proceed. It says, in the diagram below, the diagram below shows a pennant in the shape of an isosceles triangle. The equal sides each measure 13. Oh yeah, sure. 13, okay. The altitude is x plus 7. The altitude is x plus 7, and the base is 2x. Wait, hold on a second. What are you talking about the altitude? This doesn't look like an altitude. Yeah, actually it does. Look, if you put it like this, it's an altitude. It goes from the vertex angle to the base. It's always like that. The vertex angle, oh, and it's perpendicular. Alright, so what do they want? What is the length of the base? Justify your response. The base. Okay, I'm just gonna give you a clue right now before you start working. The base is right here. We have two right triangles right here. You see it? Right triangle. So you choose which one you wanna work with. Now, if the length here is 2x, and even if you don't know, the altitude drawn from the vertex angle to the base, okay, divides or hits the midpoint of the base. So that means that if this whole thing is 2x, then this is x and this is x. Okay? Okay then. Now, what is the length of the base? Justify your response. Okay, take 2 minutes to work on this problem. I'm counting on you. Alright, so let's see if you got it. So this is a right triangle. So in a right triangle, I'm going to find each of the sides. So what do I know? Well, the hypotenuse is 13. So I'm going to write 13 square, okay, equals to, remember, the sum of the squares of each of the sides. So x plus 7 square plus x square. Alright, if you already got the answer, you could tell me. If you didn't, and you're still following along, tell me x plus 7 square. What is that equal to? Say it before I write it. Okay, so x plus 7 square means x plus 7 times x plus 7. But since we already did a lesson on one of the quizzes, there was problems on how to square binomials. I know that I square this term, I take these two together and multiply by 2, so 7x times 2 is 14x. And then I square the last term, which is this one, plus 49. Then this x squared, okay, so plus x squared. Perfect. Now, I'm going to add the like terms. So first, 13 squared is, I think, 169. Okay. Now that I have the problem set up right here, then I could zoom in right here so you could see it better. Okay. So 169 now. X squared plus x squared is 2x squared. Plus 14x plus 49. Now, this is called a quadratic equation. A quadratic equation should equal to 0. So, I'm going to take this 169 and I'm going to put it on the other side. So, it automatically becomes 0. Okay? In equations, you don't have to say, oh, I'm going to subtract 169 from both sides. It's understood that if you subtract 169 from here, you're going to end up with 0. And it is understood that you're already subtracting 169 from here. Alright then. So now, what do I have? 2x squared plus 14x. And now tell me, what do I get? What is 49 minus 169? Correct. It's negative 120. So, minus 120. Alright, cool then. So now, I need to solve this quadratic equation, and we already know how to solve it. First, I can solve this by factoring. So let's factor this. How do I factor this? Easy. First, find the greatest common factor, which is 2 in this case. If I divide the whole thing by 2, what do I get? Good. Now I proceed, sorry, now I proceed to open the parentheses, like if I'm going to factor, so. Okay? So factors of x squared, factors of 60, and I need to get a 7. Woo! I don't know, 12 and 5. Yes, 12 and 5. 12 and 5. I need a 7, so I'm going to put plus 12, and I'm going to get minus 5. Now, you guys, if you're not used to doing this, then you do the smiley face. So you could get the middle term of 7. Me, I already knew it. So now, I have to equal each of the factors to 0. Well, this is not a variable, so this doesn't count. Now, this one counts. What number plus 12 is 0? Negative 12. What number minus 5 is 0? X equals to positive 5. So now I'm measuring, so I cannot just use a regular number. I have to use a positive number, not a negative, because we don't say, oh, look, there is negative 6 inches over here. This measures negative 12. Pause. Okay, so I'm going to use x equal 5. So your answer right here, x is 5. Question is, what is the length of the base? So, think about it. The base measures 10 because you have 5 and 5. That's the base. So that's it. All right. Let us do this problem now. Once again, take 2 minutes. See if you can do it. If not, you're going to have to follow along with me. Okay, so I'm assuming I paused the video and I'm just going to do this problem. So I have 2 right triangles right here. They measure. The question is, what is the measure in inches of the vertical support bar? They want this support bar. Okay, so 1 right triangle, another right triangle. I got some measures, so that's not a problem. What do I know? By the Pythagorean theorem, okay, because I have a right triangle, I know that c squared equals to a squared plus b squared. So it's just a matter of labeling this, okay. If this is the right triangle, which one is the hypotenuse? I know that this is the hypotenuse, okay? This is going to be C. How do I know that? Because it's opposite to the right angle, or from here, whichever triangle you're working with. All right, and remember, this is x inches, this is x inches, this is 7, this is 7, okay? All right, then, so let us get to work on this. Okay, that's what I get. Now, for 1 point, if you already know it, what is x plus 1 squared? Okay, I'm squaring a binomial. So I know that I'm supposed to square this. I take this together, 1x, and I multiply by 2. And then I square the 1. Well, 1 squared is nothing more than 1. Okay, then I got x squared plus 49. Because I squared them. Now this, well, so far it's a quadratic equation. I'm not sure, so I'm supposed to make it equal to 0. But the funny thing is that let's go step by step. Let us subtract x squared from both sides. If I subtract x squared from here, this cancels out. Guess what? If I subtract x squared from here, it also cancels out. Therefore, that leaves me with 2x plus 1 equaling 49. Guess what? It's not a quadratic equation anymore. Now it's just a regular equation. So I'm going to solve for x. So I'm going to subtract 1 from both sides. So I get 2x equal 48. Then I'm going to divide by 2. So x equals 24. Alright then. So now you tell me, what is the length of the support beam? Raise your hand if you want to answer. I'll give you 1 point. Well, okay. I don't want to say you're wrong. I'm going to say, look at the support bar right here. The measure of the support bar is x plus 1. What is x? 24. 24 plus 1 is 25. Oh, I thought it was 24, but it's not. It's 25. And that's basically what it is. All right, summary. Write a brief explanation of how problem 1 on the independent activity was solved. Oh, sure. Problem 1? What is problem 1? Oh, it's talking about the Pythagorean triplets? Well, you do it. I won't. Alright, guys. So now, quiz number 24. So in right triangle DEF, measure of D is 90. So I already know, well, I knew it was a right triangle. So let me just draw a right triangle. Sort of a right triangle, okay? It's not gonna be perfect. Oh, it's perfect. So this is D, because that's the measure, 90 degrees. Measure of F is 12. Okay, I'm gonna put 12 over here. So measure of F is 12 degrees less than twice the measure of E. But I don't know what E is, so that tells me what E is. It's an unknown, so it's X, so 12 less than 2 times the measure of E, which is X. Alright, so what do they want? Find measure of E. They want me to find the measure of E. Okay, so you've seen this problem before. This problem has been given to you in the previous lesson or 2 lessons ago. So how am I gonna do? I know that all the angles in a right triangle add up to 180. So I could write all 3 angles and add them up to 180. But then again, I have another strategy. This angle is already 90. If this whole thing is 180 and this is 90, that means that there are 90 degrees flying between these 2 angles. So I don't need to add all 3 angles. All I need is to add these 2 angles. You understand what I'm saying? Look, 2x minus 12 plus, let me put parentheses on the angles, okay, plus x equals 90. Now I add the like terms. 3x minus 12 equals 90. I add 12 to both sides, so I get 3x equals 102. Now all I gotta do is divide by 3. So x equals 34. On your answer, you write measure of angle E is 34. Okay? Cool then. Alright, the next question. In triangle ABC, okay. Measure of A is x, measure of B is 2x plus 2, and measure of C is 3x plus 4. Oh, they gave me all of them. Okay, what is the value of x? Sure. Take all the angles and equal them to 180. So x plus 2x plus 2 plus 3x plus 4 equals 180. Alright, so I'm just gonna add the like terms. So x plus 2x is 3x plus 3x is 6x, so I got 6x. Then 2 plus 4 is 6, so 6x plus 6 equals 180. Subtract 6 from both sides, so you get 6x equals 174. Then you divide by 6, get, what do you get? $29. Alright, cool then. The angles in this are in the ratio of 8 to 3 to 4. What is the measure of the smallest angle? What did I say about angles that are in a ratio? Just add a letter. Okay? Add a letter. Add them, since there are 3 angles, so that they equal to 180. 8 plus 3 is 11, that is 15, so 15x equals 180. Okay, you divide by 15 and you get 12. Question is, what is the measure of the smallest angle? Look, you got a choice that says 12 here. It reads 12, but guess what? That's not what they're asking you for. They ask you for the smallest angle. The smallest angle out of 8x, 3x, and 4x is 3x. So you substitute here and you show the work, okay? In other words, 3 times 12 equals 36. So you're right, the measure of the smallest angle is 36. And there you go. All right. So we're good with that. What else do we have? Nope, we're moving on to the next lesson. All right, so I'll see you on the next lesson. Bye.